Lesson 1. We're going to be starting a new unit, and this is units on fractions. I can decompose fractions as a sum of unit fractions using tape diagrams. So here we have, this is a whole. It's all colored in, and it's broken up into 3 pieces. And when we are dividing up a tape diagram here, we know that the denominator is how many pieces it's cut up into. And the numerator is telling us how many pieces are shaded in. So 3/3 is a whole, because this is representing a whole. And when we talk about decomposing fractions, look on down here. 1/3 plus 1/3 plus 1/3 equals 3/3, which is really a whole. So this is how we can break down, decompose a fraction. So decomposing fractions, we are taking the pieces apart, and composing the fractions, we're connecting the pieces back together again. So you can see over here, we got this little hammer. That means we're breaking apart this whole and making it into each individual fourths to make 3/4. And over here, we're putting it back together. It's like using the glue, taking 1/4 plus 1/4 plus 1/4, which is 3/4, and putting them back together again. That's composing the fractions. So the denominator is how many pieces it's cutting up into, and the numerator is how many pieces that are shaded and or taken out. So the denominator is saying how much it's broken up into, and the numerator is how much it's shaded or taken out. Over here, if you look how many different ways we can make 5/6. When we're decomposing fractions, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. We can say over here 2/6 and then plus 1/6 plus 1/6 plus 1/6 equals 5/6. So the only difference is here is that we just put 2/6 together. And down here is 3/6 plus the 1/2 Then another way of you can write it is 3/6 plus 2/6 equals 5/6. And another way is 4/6 plus 1/6 equals 5/6. So these are all different ways of decomposing 5/6. So with this next one, we see a tape diagram. And this tape diagram is going to represent a whole because it's broken up into 6 pieces. 1, 2, 3, 4, 5, 6. And that represents the denominator, which is 6. But only 1, 2, 3, 4, 5 is shaded in, and that represents the numerator. So we want to decompose 5/6 and create a number sentence decomposing 5/6, which would equal 5/6. So each one of these represents 1/6. So all these different ways that we can create 5/6 is we can group this one together, which would represent 2/6, and we can group this together, and that would equal 3/6. So 5/6 can be 2/6 plus 3/6 equals 5/6. We also can do 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 to represent 5/6. If we wanted to create a number bond using 5/6, we would put 5/6 up in the top, and then using our number sentence, 2/6 plus 3/6 equals 5/6. And 7/4. Now that one looks a little different, I'm sure, to you right now, because in the numerator is 7 and the denominator is 4. And this is it would be considered an improper fraction because our numerator is bigger than our denominator. But what we need to do is we need to create a tape diagram that represents 7/4. Now notice it's broken up into 4 pieces. but we have to color in 7. So let's take a look at this. So I'm going to start making my tape diagram. And here's my first piece. And remember, it's broken up into fourths. So I want to make sure that my tape is broken up into fourths. I know my drawing is not an equally arranged the boxes, but this is going to be colored in. This is going to be colored in. This, and then this last piece. But notice there's only 4 pieces colored in, and we need to have 7 pieces colored in. So that means we need to create another tape diagram. So underneath it, I'm going to create another one. Next to it. And I'm going to make it into fourths. And again, it's not perfectly measured out each box, but over here I have 4, and now I colored in 4. Now I'm going to color in 5, 6. I'm sorry, so this is 6, and then my other one is 7. And now this represents 1, 2, 3, 4, 5, 6, 7 represents 7 colored in, and they're broken up into 4 pieces. So it really wasn't into 2 holes. So this is showing that we have a hole here. So this is a hole, and over here is showing me 3/4. Okay, and so all of this together is equal to 7/4. So if you have over here, that 1 really just says 4/4 plus the 3/4 does equal 7/4. So if we wanted to create a number bond to represent this, 7/4 would be up on the top, would be in the top. And then showing our number sentence, breaking it up, 7/4, 4/4 plus 3/4 gives us 7/4. Okay, in our next problem, we see something that looks a little tricky to us. And we have to first identify what is the whole, because we got to figure out what the denominator is going to be. So if we look over here, we see that it is broken up into 1, 2, 3, 4, 5, 6. But that is not the whole. The whole is this. This is the whole. This section is not included in that whole. So how many is it broken up into? How many parts? 1, 2, 3, 4, 5. So this is broken up into fifths, not sixths. So when we are writing this out, we need to actually identify 1/5, 1/5, 1/5, 1/5, and 1/5. This is a fifth over here also. So basically, it's going to be 1 and 1/5, or you could say 6/5, because there are 6 in the numerator, and it's broken up into 5 pieces. So here's your whole, and then you have an extra fifth. So we could either say 1 and 1/5 or 6/5. In our next example, we see in letter A, we see a hole here, and only 1, 2 is shaded in. This one is not. So there are 2 sections that are shaded in, but it's broken up into 3 pieces. So that's why it becomes 2/3. 2 are shaded in, and it's out of 3s. So if we decompose 2/3, it would look like 1/3 plus 1/3 equals 2/3. And if we use our number bonds, we see 2/3, we got 1/3 plus 1/3. So over here, our section, we've got 1/3 here and 1/3 here. If we added another third, it would be 3/3, which would equal a whole. Now we see on letter B, we see that this whole section is a whole, but only this and this section are shaded in. So what is the denominator? Well, we have to see what it is broken up into. We have 1, 2, 3, 4. So this one is broken up into fourths, but only 2 are shaded in. So that means the numerator would become 2/4. So this one would be 1/4, and this one would be 1/4. And how would that look like as a number bond? Well, we would have 2/4 in our big circle, and then we would decompose it. 1/4, and then another fourth, because 1/4 plus 1/4 equals 2/4. In the next one, we have a whole. This is the whole right here. This whole thing is equal to the whole. And we got to first figure out what is that broken up into, and that will give us the denominator. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is broken up into eighths. And we first have to see what is it shaded into. But boys and girls, check this out. Look at how they grouped this one and this one. They grouped it together, and then this one is by itself. Well, if we know it's broken up into eighths, this is a 1 and this is 2. So how many are shaded together out of the 8? It would be 2/8. And this one is by itself, so this one would be 1/8. So how many are all together? Well, we've got 2/8 plus 1/8 equal 3/8. And we decompose it, it'd be 2/8 plus 1/8. And if we wanted to make it look like the number bond, we would have the big circle, we'd have 3/8, and we would decompose it as 2/8 and then 1/8. Okay, so when we look at this, we have to be careful when we see these arrows, because these arrows are telling us that we're grouping these two boxes together, and this one is separated. So we're saying 2/8 plus 1/8 gives us 3/8. And the next one, wow, look at this one. This one looks really tricky. Let's first find the whole. Let's see where the whole is, and the whole is this section right here. This is the section of the whole. This part, these 4 over here, is not part of the whole at all. And notice how they're grouping them. This is a 3, this is a 2, this is 1, this is a 3 grouped together, and this is the last 3 that are grouped together. So let's see what the whole is broken up into. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8. We have to stop, because this is where the end point is. We're showing us that this part is just the whole. So this is broken up into eighths. So this one up here is really representing 8/8. Okay? And these numbers over here, this section over here, are just some extra boxes that they've added on to this whole that we also have to include, but it's not part of the whole. Okay, so we are dealing with 8/8 now. So let's check out those individual boxes and see how they are grouped together. See, this is 3. All right, so when we write it, we want to make sure we write 3/8. And then the second one is showing us just 2 boxes that are grouped together. So this would mean 2/8. Then the next one is just 1 by itself, and that's 1/8. And then if we continue on, check this out. Change this. We've got this section here. Look at that. That is being grouped together. So it's going over that whole. So this part is becoming 3/8, and that last section is grouped together as 3/8. So now, how much do we have? 3/8 plus 2/8 plus 1/8 plus 3/8 plus 3/8 equals 12/8. And if we were going to just show how this can be broken down, we would put 12/8, which is considered improper fraction because in the numerator there's a 12, and it's bigger than the denominator, which is an 8. So they called this an improper fraction. So this is 3/8, 2/8 in our number bond, 1/8, 3/8, and 3/8. So this is our number bond representing this tape diagram. So now we could say 12/8. Well, to get us to a whole, we would have 8/8, right? So if I take away 8 from 12, what would we have in the numerator? We would have a 4, and the denominator stays the same. So it would this would represent 12/8 or 1 4/8, because there, in order to be a whole, it has to be 8/8. So there would be 8/8. So we take 12 minus 8, and that would give us left over 4. And it would be 4/8. So our answer to this tape diagram, 12/8 equals 1 4/8. So either one of those are acceptable. In our next one, it says 5/8 equal 2/8 plus 2/8 plus 1/8. So it's been decomposed. And they want us to draw and label tape diagrams to match the number sentence. So we notice that the denominator is an 8. 8, 8, 8, 8. So our tape diagram needs to be broken up into 8s. So here I have the tape diagram, and this whole thing equals to 1, which is really 8/8, right? And so our denominator is 8. So now if we look over here and we see the first one we're adding is 2/8. So we want to group together the first two. Now let me make that a little better. And okay, I chose the wrong tool. Okay, so over here is 2/8. And then the next one says we're grouping another 2/8 together. And then the last one says 1/8, so that's just going to be 1/8. So this represents 1/8, 2/8, and that's 2/8. And then they grouped another one, 1/8 plus 1/8, that would give us 2/8. And then the last one is just 1/8 by itself. And this this represents 5/8. In our letter B, it's 12/8 equals 6/8 plus 2/8 plus 4/8. Now, if you notice that 12 is the numerator, and it's greater than our denominator, and it's called an improper fraction. So we know that there's going to be a whole in there, and there's going to be another fraction attached to it. So this is like one of those little awkward type of tape diagrams. So we know that we are going to have 8s. It's going to be broken up into 8s. So because our denominator is an 8. So let's make our tape diagram. It's going to be kind of tight. So here we have a tape diagram that is cut up into 8s, and this represents 1, which really is 8/8. But boys and girls, check out the numerator. It's a 12. So that means I need to add on an additional section to our tape diagram. So I had to add on this additional right here because it's 12/8. This is 8/8. I needed to add on another 4 because it has to equal 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is now our tape diagram. And this section in the black is our whole, and this is the other part of that other fraction. All right, so let's start grouping it together. In there, decomposing there in our number sentence, it says 6/8. So let's count. We've got 1, 2, 3, 4, 5, 6. that section is going to represent our 6. Our 6/8. And then in our decomposing number sentence, it says 2/8. So this part is going to represent our 2/8. And then we have 4/8. So this last red section is going to represent our 4/8. So this up here is 4/8. So what does it look like? It's going to become 8/8 is our whole, right? Just want to show that to you again. But we have 12/8, or we could say 1 4/8. Because if we go back to this over here, 12/8, 8/8 is a whole. This part is our whole. This is 1. And then we added another section to this tape diagram, which is our next fraction of 4/8. Okay, in our last one, they're giving us a mixed number, and a mixed number is a whole number that's attached to a fraction. And they're saying that it's basically 1 1/4 is equal to 1 whole plus a fourth. And they want us to create a tape diagram showing that. So let's show a tape diagram. Well, we are going to have 1 whole. And how do I know what to split it up into? Well, it's that denominator that tells us what we have to split that whole up into. We're splitting it up into fourths. Okay, so there's our fourths. But notice that there's plus another fourth. So let's represent this section right here as our whole, which is really 4/4. Okay, but then we have to add on another box that represents a fourth. So how many do we have? Well, we have 1, 2, 3, 4, 5. We have got 5/4, or we could say 1 1/4. The more you practice, the better you get. Let's continue on and see how well you can do this evening. Please show me what this tape diagram is representing, how they're grouped together, and what they're adding up to, and I want to see your work tomorrow. Again, problem number 2. Show them how they're grouped together, what they're equal to, and I want to see your work tomorrow. And your last one. What is this all grouped up together? Show me the decomposing number sentence for this, and I want to see your work tomorrow. You rock! Good job tonight, guys. Have a wonderful night.